We rely on scientific models for literally everything, from guessing tomorrow's weather to figuring out the state of the economy. But what happens when those models get it spectacularly wrong? Well, in this explainer, we're going to dig in and find out what's really going on. So here's the big question, right? The central mystery we're going to try and solve today. Have you ever checked a weather app that promised a beautiful sunny day, only to get completely soaked in a downpour an hour later? Well, guess what? That's a model failing right in front of your eyes, and we are going to investigate exactly how and why that happens. Okay, so to get to the bottom of this whole thing, we've got to understand the main character in our story, the model itself. And I want you to think of it less like a crystal ball and more like a map. It's a fantastic guide, for sure, but just like any map, it has its limits. So what is a model, really? Well, at its core, it's just a simplified explanation of a super complex reality. It's not the actual world itself, but a representation of it. And this simplification is what makes models so incredibly powerful, but, and this is the key, it's also their hidden vulnerability. And you've seen these models everywhere, right? They come in all shapes and sizes, and a lot of them are probably familiar to you. We see them as simple graphs in the news, we remember them as equations from science class, and of course, there are those complex computer simulations that predict big things, like climate change. They are the tools we use to try and make sense of this complicated world. Okay, now this is the crucial clue. This is the real secret. Every single model, no exceptions, is built on a foundation of assumptions. It has to simplify reality. It does that by ignoring certain factors and focusing only on a few key ones. This is exactly what allows it to work, but it's also the secret to why it can break. All right, let's move on. Let's go to what I like to call the scene of the crime. This is a place where a perfectly good, really reliable model can suddenly, spectacularly fail. And it all has to do with stepping beyond the edge of what that model actually knows. This slide really gets to the heart of it. We've got two key ideas here, interpolation and extrapolation. Think about it like this. Interpolation, that's like using a map of your city to find a street that you know is on the map. It's safe, it's reliable, no problem. Extrapolation, on the other hand, that's like trying to guess the street layout of the next town over using that same map. You're literally off the map. You're in uncharted territory. And that's where things get risky. Okay, let's make this super concrete. This thermometer is a perfect example. Imagine you build a scientific model based on a bunch of tests you ran, but only between 10 and 40 degrees Celsius. You can be pretty darn confident in its predictions at, say, 25 degrees. That's interpolation. But what happens if you try to predict something at, say, 90 degrees? Whoa. That is pure extrapolation. The rules of the game that applied at cooler temperatures might not work at all when things get that hot. So it's not just about pushing the numbers too far. Models can also completely fall apart when new, unexpected things pop up. Maybe your temperature model didn't account for humidity at all. Or maybe, and this happens all the time, the real world simply has layers and layers of complexity that your simplified model just completely ignored. These are the classic ways a good model goes bad. Okay, so we know how they can go wrong. The big question is, how can we get better at spotting this? How can we become model detectives? Well, let's do it. Let's equip ourselves with a super simple 5-step toolkit to check any model we come across. Okay, this is your go-to checklist. It's super straightforward. First, just figure out what you're looking at. Is it a graph, an equation? Step 2, and listen, this is the big one. Find its data range. Where are the edges of its map? Step 3, check it against reality. Do its predictions actually match what you see in the real world? Step 4, always be asking, what's missing? What important stuff might this model be ignoring? And finally, step 5, you make the call. Is this a trustworthy prediction, or is it a risky leap of faith? But even with a great toolkit, it's really easy to fall into a few common traps. So what are the pitfalls we absolutely need to be aware of when we're putting on our detective hats? And here they are, the classic mistakes you've got to watch out for. The biggest one, by far, is just assuming a model is some kind of universal truth that works everywhere. Another is blindly trusting predictions that go way outside its original map. And here's a critical one, confusing correlation with causation. Just because ice cream sales and shark attacks both go up in the summer, that doesn't mean one causes the other. All right, so after all of this whole investigation, what's the one big idea, the one golden rule we need to walk away with? Well, luckily, it can all be boiled down to a simple, powerful rule for thinking like a healthy skeptic. And here it is. I love this. It's like a simple formula for success, for being a smart skeptic. The strength of any model really just comes down to two simple questions. Does it work within its known tested range? And do its predictions actually match what we see in the real world? If the answer to both is a big yes, you've got a strong model. If not, it is absolutely time to be skeptical. It really is that simple. So at the end of the day, it's all about staying curious and, just a little bit critical. The next time you see a forecast or an economic prediction, just ask yourself, what model is this based on? And maybe more importantly, where's the edge of its map? Thinking this way really is the key to navigating a world that is just full of data. Thanks for digging into this with me.